This is Algebra 2, Lesson 8.4, logarithm, Introduction to Log Functions, Evaluating and Graphing. We'll get to graphing of them way at the end on page 486. First one's a definition of a common logarithm. It's base 10. Tens are good bases for the same reason you do scientific notations in tens. Because what it does is it allows you to just move the decimal over to the right or to the left based on if it's negative or positive. For that. So base 10, natural logs or natural logarithms have a base of e. This is another one of those special numbers like pi. And again, we'll introduce that. We'll talk very briefly about what e is. But instead of saying log for these, like a log with base 10 is going to look like this. Log base 10 of 2 equals, so what that's saying is 10 to what power gives you 2? That's a bad example I know I used, but let's say 10 to log base 10 of 100 is equal to what? And it's just 10 to the second power. That's for bases. That's for common logs with base 10. When you're talking about natural logs, instead it'll say the natural log of it, ln. So if you see that ln, don't freak out. Again, I'll show you what I mean when we get to those. The definition of a log with base b says let b and y be positive numbers, so you're not talking about negatives yet. And let b not equal to 1. Says the logarithm of y with base b is denoted as log base b of y and is defined as follows. This is the biggest key to all of this, and I told this to about 4 or 5 of y'all a little while ago. Reading it like it's written. Don't read it as log b. That's a very, very common mistake people make, and for the most part, you'll be able to rewrite it the correct way. But if you read it as log base b, if you simply just say that word base, it'll just help you set it up so much easier, because you know bases go at the bottom. They're the big thing that you raise the exponents to. So log base b of y is read like that. Example number 1 says convert all of these to exponential form. Again, read them as log base 3, so base 3 of 81 equals 4. And if you'll notice, this looks like the bell work we did, and it's for a reason. Log base 3 of 81 equals 4. The same thing with the other one, b. Log base 4, so log base 4 of 1 equals 0. So notice, on the other side of the equal sign, those are all of the exponents. The base is the small subscript number, base, and then the of 1 part is what you're actually trying to get to. So the next one, you'd read it as log base 9 of 9 is equal to 1. 9 to the first power is equal to 9. Log base 10 of 0.01 equals negative 2. This was just like number 4 on the bell work, except instead of moving it 3 times, we only move it twice for this one. But you raise it to the negative second power because you move it twice. And then log base 1/4 of 4 is negative 1. 1/4, and this was like number 5 on the bell work, to the negative 1. That's the reciprocal. It flips both of them. Well, it flips it. One of them goes up, one of them goes down, and it becomes 4 over 1. That's just like number 5 on the bell work. Okay, the first checkpoint says write each of these in exponential form. If you read it correctly, you would read this as log base 3 of 3 is 1. So log base 3, that's this one, of 3, that's this one, is 1. So that's what you should have. 3 to the first power equals 3. And you can check that. You know 3 raised to the first power is 3. Log base 2 of 0.125 equals negative 3. Base 2 of 0.125 equals -3. You know, if it makes a decimal number, something smaller than 1, it's going to have to be a fraction because it's going to have to ride the elevator. And then how many times do you raise 2 to itself to get 0.125, which is 1/8. This is the equivalency of 1/8. Here are special logarithmic values. Let b be a positive real number such that b is not equal to 1. Log of 1, so log base b of 1 is equal to 0. So this is just talking about the logarithm of 1. It's equal to 0 because anything to the 0 power is 1. When something has a log base b, notice for this one, and we had one like this a minute ago, the base is the same as what you're trying to make. The same as what you're trying to become. It's going to be 1. So if it's the log of 1, it's going to be 0. If the base is the same as what you're trying to get, it's going to be 1. He's evaluating these. Evaluate log base 2 of 64. So it's saying 2 to what power equals 64. So you're just saying, how many times do I have to multiply 2 times itself to get 64? We know 2 times 2 is 4. Times 2 more is 8. Times 2 more is 16. You got to go 6 times. 2 times itself 6 times. So when you rewrite it in logarithmic form, it's going to be equal to 6. So this is called exponential form. 2 to the 6th equals 64. The one I have circled is called logarithmic form. Log base 2 of 64 equals 6. The next one, log base 1/2 of 0.25. So right here, log 1/2 to what power is 0.25? We know 0.25 is the same thing as 1/4. Don't let the fact that there's both fractions and decimals confuse you. Convert them both to fractions, make it easy. So 1/2 to what power equals 1/4? That's what it's asking you. And that's being raised to the second power, because when you do 1 to the second power, it gives you 1, and 2 to the second power gives you 4. So it's base 1/2 being raised to the second power is 0.25. Log base 1/3 of 27 equals what? Again, 1/3 to what power equals 27? Okay, first off, in order to make it from 1/3 into an integer number, a number that's not a fraction, you have to make it ride the elevator. The 3 from the bottom has to go up. How do we make something go up? It's got to be a positive or negative? It's got to be negative to make it go up. So right away, it's going to be a negative exponent. Then ask yourself, 3 to what power is 27? We know 3 times 3 is 9. Times 3 more is going to be 27. So it'll be to the negative third power for that one. And then the last one says log base 4 to what power, or log base 4 of 2 is equal to what? 4 to what power is 2? So for this one, you're going to have 4 to the 1/2 power, because when we take that, remember, something to the 1/2 power, four to the 1/2 power equals 2. I'll show you guys another example, make a little better sense out of that one in a little bit. 4 to the 1/2 power. So right here we have log base 5 of log base 5 of 125 is what? That's all you're trying to do. You're trying to find out what is the exponent. 5 times 5 is 25. Times 1 more 5 is 125. So 1, 2, that's 3 of them. So 3 is the correct answer. And then log base 8 of 2 is what? You have to raise 8 to the 1/3 power because 2 times 2 times 2 is going to give you 8. So if you raise 8 to the 3rd power, think about it in reverse for a second. 8 to the 3rd power means 8 times 8 times 8. That's not going to work. So 8 to the 1/3 power, it's you're doing the inverse of raising it to the 3rd power. You're going backwards with it. You're doing 2 times 2 times 2. So think backwards when you're talking about going down to a smaller number. That's not small. That's not a fraction. When you're just going down to a smaller integer number, just work backwards through your exponents. 1/3. Okay, here's some more inverse properties. It says log, this is the inverse when you're doing the base 10 raised to the logarithm of 2.3. So right here, anytime you have 10 being raised to the log of 2.3, it's going to be 2.3. That's an inverse property. So whatever it happens to say it's being raised to, it's almost like these two cancel each other out and give you 2.3. So right there, for the next one, it says log base 2 of 8 raised to the x power. Okay, got a lot of stuff to do here. So look at it real quick. Log base 2. What we're trying to create is we're trying to separate these two real quick. Log base 2 means this is going to be 2 to what power? That's what you're asking yourself. 2 to what power gives you 8? We know 2 to the 3rd power is 8. And that's still being raised to the x power. So it almost looks like this. I know that looks funny. That's why they only have it written as 2 to the 3rd power in parentheses, because it does that. It's still, however, being raised to the x power. I know this is throwing a lot of y'all off right here. You thought you had it for a second. Just bear with me for a little bit. Okay, we're not going to get too deep into it. What that gives you is 2 to the 3x power. So right now we have log 2, log base 2 of 2. Just like this one cancels this one out, log base 2 of 2 cancels those out. So what you're left with is simply 3x for that one. It gets better, I promise you. That's the inverse. And here's finding more inverses. It says log y is equal to the log base 1/2 of x. Log base 1/2 of x is what? So it's saying 1/2 of it, it's going to cancel out, and it's going to be 1/2 raised to the x power. We'll come back more to inverses tomorrow. I didn't want